Okay, I wanted to put together a video to review how to measure voltage and current in series and parallel circuits. Today, my cameraman is Steven and my lab assistant is Leslie, but you won't see her because she's invisible. All right? You might see her hands every once in a while, but she doesn't want to be seen on camera. Right, Leslie? She's nodding. Okay, so what I have here is this setup here. Is this I'll start with a 247 ohm resistors in series. Okay? And I put it down here, and I'm going to hook up my voltage like this. And I'm going to use a short cable. And some of you might figure out why I'm using this short little cable right there. And then I'm going to turn the power on. I've got 10 volts going across it. So what's my voltage going to be across here? What do you think? Say something. Okay, Steven, you say something since Leslie won't.
The question? Yeah, give us.
You can hold up your hands even if you want. All right, it should be 10 volts. If we look here, and don't do that. You see, what I've got is I don't have this thing set up to measure voltage. You have to move this guy over to here. The black one always goes to COM, and since we're measuring voltage, this has got to go on the V one. Then you flip this guy over here. In this case, since we said we got about 10 volts, we put it on the scale of 20. And now if we measure this across here, we get 10 volts or so. Does that make sense? They said yes, trust me. All right. So now, what is the voltage going to be across the resistors? Well, 10 volts. Big surprise. Now what that means is that from here, from one side of the resistors to the others, we lose 10 volts. Now, what does that mean? Well, since we have two equal resistors, that means we're going to lose 5 volts across the first resistor and 5 volts across the second. Can we prove that? Of course we can. If we take the voltage and we measure it from here to here, what do we get? 5 volts. All right, so the voltage drop across the first resistor is 5 volts. And then if we do it across the second resistor, it's also 5 volts. Well, that works out pretty easily because these are the same resistors. But what would happen, you ask, if we use two different resistors? Well, I take out one of the 47 ohm resistors and I put in a 470 ohm resistor. Okay? And now, what do I get for voltage across here? Well, first I'm going to get 0 because I haven't turned it on. It's kind of important to turn it on, don't you think? So I'll turn it back on, and I still get 10 volts, except I reversed them. All right? Now remember, this resistor is 1/10 the size of this resistor. So if we look at this, this is going to be only 1/10 of the drop. In other words, just about a volt. So what do you think the resistance drop across the other resistor is going to be, since it's 10 times bigger? 9 volts. You can hold up your hand so they can see them, maybe. No, Leslie's not being a very cooperative lab assistant today. It should be about 9 volts. And we put it across there, and it's about 9 volts. When you add these two voltage drops together, 9.1 and 0.9, you get 10 volts. So that's you have to have that. It's just like conservation of momentum or any of those other conservation ones. The voltage across these things has to add up. This is in series. Now in parallel, all bets are off. But now how do we measure the current through this? Well, the first thing we do is we move this guy over here. Leslie's pointing, very good. We move this guy back over here to the 20 amp max one. This is the one you want. Actually, no, don't do that. Use it over. It doesn't really matter. You're probably not going to blow a fuse. Let's use the 20 amp max one. And then you flip this thing over to 20 milliamps, say. All right. Now we can see on here that it says it's got 0.02 amps. That's 20 milliamps. So maybe we should put this on 200 milliamps. We'll try it. Now, where do we measure the current? Well, current, what you have to do is you have to break the circuit and measure the current as the electricity is going through it. So you become part of the circuit. You become part of the problem. So let's take this out, and right now we can see there's no current going through because we don't, instead of having a short circuit, we have a long circuit. I just made that word up. All right, so now we put this guy here and this guy here. And what we get is, well, it's over to 20. Yeah, okay, it does that scaling thing on it. And it says we're getting 20 milliamps, 0.02 amps. Now, the question I would have for you is, what's the current, if I put that back in, through this resistor? And the answer is, it's still going to be 20 milliamps, because that's the current that comes through it. Think of this as like water. You have 20 milliamps coming into here. It's got to go somewhere. The water doesn't go anywhere else. You don't see bunches of electricity just laying around in the circuit board, do you? It's got to go somewhere. It's got to go all the way through. So we can prove that, and the way to prove that is we could just take this here. Let's turn this off and be safe for once. And we move this guy over here to over here. Okay? Now, if we measure the current out the back side, just like this, we turn the power back on. What did I do wrong? Oh, something fell apart. Okay, don't do this at home. Okay, now we should get... Why the hell aren't we getting... We're getting no current. Why is that? Do you know why?
Is that part of the test?
Well, it would be a good part of the test, except I can't figure out why it's not working. It should work. Maybe I've got it reversed. No. Well, looks like I didn't have it reversed. I wonder if I'm not getting the connection right here. Let's try it. Let's try it direct to here. Well, this is bizarre.
Well, see, it's not at
Right, it's not saying it's.
2 there, so.
Yeah, it's not coming out here. Let's put it back to where it was. See what I messed up. And yes, that was the voice of Leslie, lab assistant. That was her finger in the picture. Well, this is unfortunate. What have I done wrong? Let's put it over onto the... Okay, now it's working.
That's not right. Oh, yeah.
Well, it says it's 19.03 milliamps. Okay. So now if I put it, let's just put it back over to here. I don't know what I did wrong for sure. You know, it's just one of those things. So let's do this experiment one more time. Put it back in here. Turn it on. 0 right now. And now we're getting 19 milliamps. So it's the same. As long as I'm holding it, getting it good contact, which I'm trying to do while I'm talking and I'm not doing a good job of. Okay, so that's voltage and current in series. The one that gets people confused the most, though, is voltage and current in parallel. So let's stop this video and then record a second video just for the parallel one. Okay, so kill it.